My name is Gyozo Akamune. I'm an undergraduate student. Today I'd like to talk about my study. My presentation title is Water Content Measurement in Cornified Layer by Terahertz Spectroscopy. What is background? Our skin consists of three layers. They are hypodermis, and dermis, and epidermis. Especially, epidermis is composed of 4 layers, and the cornified layer is the uppermost layer of our skin. And it has many important functions. For example, it prevents water loss from our body, or it prevents invasion of microorganisms or chemical agent into our body. And the water in the cornified layer also have important function, and it keeps structure of cornified layer, and it changes permeability of skin, and it alters enzyme activity in the cornified layer, and it maintains polish of skin, and it keeps transparency of skin. So measuring water content in the cornified layer would be of great help in some cosmetics or medicines or biological research program. For example, polish of skin or transparency of skin is important for cosmetics when making cosmetics, or the permeability of skin is also important in making medicines. And by measuring water content in the cornified layer, we can assume the skin condition, for example, atopic dermatitis or the burn condition skin. The traditional method of measuring water content in cornified layer is measuring of electric conductance, or the electrostatic capacity, or NRI, or measurement of transdermal water loss, or the Raman spectroscopy. However, there are some programs in this method. For example, the measurement depth of some of this method is limited, or we cannot measure the precise water content in cornified layer after applying cosmetics or medicines. So, not affected by because of the ingredient of cosmetics or medicines, we cannot measure the precise water content in cornified layer. So, not affected by other material, or having adequate measurement depth method is necessary. So I want to measure the water content in cornified layer by using terahertz time domain attenuate total reflection spectroscopy. When the terahertz wave radiated into the ATR prism and reflected totally, the evanescent wave appears on the surface of the ATR prism. The evanescent wave penetrates up to the prism and come back into the prism. Thanks to this evanescent wave, we can get information in depth direction about the dozens micrometers of the depth, and the terahertz wave is sensitive to water. So, and by using the ATR system, we can measure the high absorption material accurately. So by using this method, I want to measure the water content in the cornified layer. In fact, the penetration depth of the evanescent wave, it differs by frequency inverse proportionally. So if I want to measure only cornified layer information, I need to find suitable frequency for cornified layer measurement. So to achieve this, I introduce contribution rate. Contribution rate is a contribution of a layer on the surface of the prism of a certain thickness to the total absorbance. The contribution rate is calculated by this equation, and by calculating the contribution rate, we can estimate measuring depth of each frequency. So I conducted model experiment. I put the film on the prism and measure absorbance by changing the thickness of film from 0 to 100 micrometer, and I put the water on the film. Then I make some layer structure Then, from the result of absorbance, I calculated the contribution rate. This is the result. The line is a theoretical data calculated by the theoretical equation, and the dot is experimental data. I get this model experiment. You can see there, I show the result at 0.5 terahertz and 1.0 terahertz and 1.5 terahertz. You can see there is high correspondence between the theoretical and experimental data. So from this data, it is suggested that we can measure only specific thickness in the multilayer material. For example, if I want to measure the 40 micrometer thickness material, in the 0.5 terahertz, the contribution rate is about 19%. So other 10% is contains other information over the 40 micrometer. In 1.0 terahertz, the contribution rate is almost 100. So in 1.0 terahertz, we can measure only 40 micrometer thickness material. Then I measure the real epidermal tissue. I use the human epidermal tissue model for this experiment. The cornified layer is about 500 micrometer, and the other layer thickness is about also 50 micrometer. And firstly, I put the epidermal tissue in the desiccator for 0 to 6 minutes, and I change the water content in cornified layer by putting epidermal tissue in the desiccator, and I put epidermal tissue on the ATR prism and measure absorbance. To get only cornified layer information, I calculated the contribution rate. The over 0.7 terahertz, the contribution rate is higher than 95%, so I regard over 0.7 terahertz region contain only cornified layer information. This is the result. I show the over 0.7 terahertz region. As you can see, the absorbance decrease as the time I put the epidermal tissue in the desiccator increase. The water content in the cornified layer may decrease as drying time increase. So this data suggests that we can measure it is possible to measure the water content. It is possible to sense the water content in the cornified layer by using terahertz spectroscopy. So next one, I will measure the real water content in the cornified layer and find the correlation between the absorbance and the real water content in the cornified layer. To calculate the contribution rate, I need to know the precise thickness of the cornified layer. So I will measure the precise thickness of cornified layer, and if the position I put the epidermal tissue on the prism is different, or if there is air between the prism and the epidermal tissue, the result will be changed. So, there is also evaporation effect. So the measurement time is limited because of the evaporation from epidermal tissue. So I need to establish ideal condition for water content measurement. Thank you for listening. I think by measuring the wet weight and dry weight and calculate the water content by measuring the weight of the epidermal tissue when they are wet and when they are dry. How long? Dry means to get the absolutely dry condition. I hear the Kusafuka-san measure the onion epidermal tissue by drying the one night in the 40-degree oven. Yes. So I need to find a suitable condition for drying.
Could you please explain what you mean by contribution rate?
Contribution. どうやるんや。
In our real skin, you showed that there is 4 layers.
Yes.
And so that in this model here,
Yes.
you only have 1 layer, the water. But in your measurement, you only want to measure the cornified. But if you measure also the next layer, then if you dry out both those layers, you're still going to get straight line. But the contribution of the cornified layer is only part of the signal that you're measuring. So do you want to measure only half the cornified layer so that you ensure that there is no interference from the layer below? Or do you want to measure until the layer boundary between the cornified layer and the next layer underneath?
If the water content distribution in the cornified layer is the same, yeah, I can measure it is okay, I measure the half of the cornified layer, but I don't know the distribution is same or not. So if distribution is not same, I need to measure the all of cornified